Quantum field theory, or QFT, is one of the most profound achievements in modern physics, combining the principles of quantum mechanics and special relativity to describe the behavior of particles and forces at the smallest scales. Imagine the universe not as empty space dotted with particles, but as a fabric filled with underlying fields, like the electromagnetic field or the Higgs field, and particles are simply excitations or ripples in these fields. When an electron moves, it's not a little ball darting through space, but a vibration in the electron field. Similarly, photons are vibrations in the electromagnetic field. QFT explains how particles interact, annihilate, and create, giving rise to the rich tapestry of forces that govern our universe, including electromagnetism, the weak and strong nuclear forces, and even gravity in certain advanced theories. What makes QFT so revolutionary is that it allows us to predict phenomena with astonishing precision, from the behavior of particles in accelerators to the radiation from black holes. Even though it's a mathematically complex theory, the core idea is elegant. The universe is built from fundamental fields, and everything we observe, matter, light, energy, is just a manifestation of these fields dancing according to the rules of quantum mechanics.